Hello, now we're going to talk about the design standards. So basically, we say that standards are specific design rules, high in authority, and are limited in applications. Standards for interactive system designs are usually set by national or international bodies to ensure compliance with a set of design rules by a large community and can be applied specifically. They require sound underlying theory and slowly changing technology. There are standards which are for hardware and for software. So, hardware standards are more common than the software, high authority and low level of detail. ISO 9241 standard defines usability as effectiveness, efficiency, and satisfaction with which users accomplishes tasks. All this is done to make the interactive design good for the user and good for the interaction. The underlying theory behind the standards say that standards for hardware are based on an understanding of physiology or ergonomics, which we have already learned, or the human factors. The results are relatively well equipped, fixed, and readily adaptable to the design of the hardware. Now, let's see about the software standards. Software standards are based on the theories from psychology or cognitive science. They are less well formed, still evolving, and not very easy to interpret in the language of software design. As we know, every day new version of software is being created. So it is difficult to make software standards which are fixed. So, for the change, hardware is more difficult and expensive to change than software, which is usually designed to be very flexible. Consequently, the requirements changes for hardware do not occur as frequently as it occurs for the software. So, since the standards are also relatively stable, they are more suitable for hardware than for softwares. Now let's talk about the design guidelines. We say that the guidelines are supposed to be more suggestive and general. There are many books, many textbooks, many reports which are full of guidelines. We say that the more specific the guideline, the more suited it is to detailed design. The guidelines can be automated to some extent, providing a direct means for translating detailed design specifications into actual implementations. Many published guidelines for interactive systems are there and are referred to as guidelines for user interface designs. There are the principles which we already know termed as abstract guidelines, which are applicable during the early life cycle activities. The detailed guidelines are applicable during the later life cycle activities. So, understanding justification for guidelines aids in resolving the conflicts at the end of the interaction design. Some basic categories of guidelines are provided by Smith and Mosier. They consider data entry, data display, sequence control, user guidance, data transmission, and data protection. All of these categories are further broken down into more specific subcategories which contain particular guidelines. We would see an example based on data entry. So, this is a guideline which is provided for data entry. Now here, the guideline which is provided is for a distinctive cursor for position designation on an electronic display. It provides a movable cursor with distinctive visual features, for example, the shape, the blinking capability of the cursor, and so on. The exception which it is supposed to handle is when position designation involves only selection among displayed alternatives, highlighting the selected items might be used instead of separately displayed cursor. There are some comments which we can view. While choosing a cursor shape, consider the general content of the display. For instance, an underscore cursor would be difficult to see on a display of underscore text or on a graphical display containing many other lines, and so on. If multiple cursors are used on the same display, for example, in case of an alphanumeric entry and one for line drawing, then each cursor should be distinguishable from other. So, for a data entry, in case of position designation of a cursor, distinctive cursor, there are some guidelines which are provided for how the cursor should be, how it should be displayed, what are the different features which it should provide, and which are the things which it should handle. Now, what are the different golden rules and heuristics? Can we say that golden rules or the heuristics are nothing but a broad brush which are going to help us to set some good design rules. They are useful for checking for a good design. They provide a better design using these than using nothing. There are different collections of rules which are provided. Some are provided by Schneiderman. I hope every one of us is aware of the golden rules which are provided by Schneiderman. Then there are Norman's 7 principles. Nielsen's 10 heuristics are also provided. We would be seeing that in the further topics later. Let's just revise the rules which are provided by Schneiderman. Ben Schneiderman talks about the 8 golden rules, like strive for consistency, enable frequent users to use shortcuts, offer informative feedback after every interaction, design dialogues to yield closure, offer error prevention and simple error handling, permit an easy reversal of action, support internal locus of control, and reduce the short-term memory load for the user. Along with that, we know that Norman has provided us with 7 principles. It is provided for the execution evaluation cycle. So, the principle says use both knowledge in the world and knowledge in the head. Simplify the structures of task. Make things visible. Bridge the gulfs of execution and evaluation. Get the mappings right. Exploit the power of constraints, both natural and artificial. Design for error. There is always a saying that to err is human. So we have to consider the human the most. When all else fails, standardize everything. We can say that Norman's 7 principles for transforming difficult tasks into simpler ones. It is based on the execution evaluation cycle. Another key feature related to HCI is making use of toolkits. So, from where did this toolkits came into picture? A key feature of WIMP interface from the user's perspective is that input and output behaviors are basically linked independent entities on the display screen, creating the illusion that the entities on the screen are the objects of interest, interaction objects. Let's see an example of a mouse as a pointing device. The input coming from the hardware device is separate from the output of the mouse cursor on the display screen, but as a visual movement of the screen cursor is linked with the physical movement of the mouse device, the user feels as if he is actually moving the visual cursor. Even though input and output are actually separate, the illusion causes the user to treat them as one. Indeed, both the visual cursor and the physical device are referred to simply as mouse. In the figure, input and output are combined for interaction with a button, as we can see over here. As the user moves the cursor over the button, it changes its finger to suggest that the user can push it. We can see it over here. After pressing the mouse button, the button gets highlighted. It gets highlighted and may even make an audible click, like the keys on some keyboards, providing immediate feedback that the button has been pushed. Releasing the mouse button unhighlights the button, and moving off the button changes the cursor to its initial shape, the original one, indicating that the user is no longer over the active area of the button. For the programmers, input and output are still quite separate for everything except the mouse, and it takes quite a bit of effort in the application program to create the illusion of the interaction objects such as the button we have just described. So, to help the programmer in merging the input and the output behavior, another level of abstraction is placed on the top of the windowing system. This is nothing but the one which is provided by the toolkits. So, a toolkit provides the programmer with a set of ready-made interaction objects called interaction techniques or gadgets, or we would say widgets, which they can use to create application programs. The application programs basically do have a predefined behavior like the buttons that comes for free without any further programming effort. Toolkits exist for windowing environments. Basically, they are amenable to object-oriented programming. The Java toolkit for developing windowed application is called Abstract Windowing Toolkit (AWT), which maps interface objects like buttons, menus, and dialog boxes onto corresponding Java classes. The programmer can build an interface by using these three classes directly. The toolkit is notification based, but the mechanism may change between versions. So we can say that the most toolkits are structured in an object-oriented manner. That does not mean that the actual application programming language is always going to be object-oriented programming language. User Interface Management System, that is UIMS, adds another level of abstraction about toolkits. Sometimes, toolkits provide only a limited range of interaction objects, limiting the kinds of interactive behavior allowed between the user and the system. So, it becomes difficult for the non-programmers and also a bit difficult for the programmers. The concerns of UIMS in terms of conceptual architecture varies. The concerns are the conceptual architecture, implementation techniques, and the support infrastructure which are provided. UIMS as a conceptual architecture provides a separation between the application semantics and the presentation. It helps to improve the portability by running it on different systems, also provides reusability, provides multiple user interfaces, accessing the same functionality for different types of applications, and customizability by the designer and for the users of the interactive systems. After separation between application and presentation, there is no need to consider how those two partners communicate. This role of communication is referred to as dialogue control. The three major components of an interactive system would be application, presentation, and the dialogue control. UIMS falls into this class of external dialogue control system. So this is about the presentation, the application, and UIMS falls under this particular typical class of interaction system of dialogue control. The CHI model of the logical components of a UIMS is shown here. From a programmer's perspective, the CHI model fits in nicely with the distinction between the classical lexical, syntactic, and semantic layers of a computer system, familiar from the compiler design. The CHI model but does not address how to build large and complex interactive systems for smaller components. Thank you.